Today's episode is going to be a really interesting one. We're going to be talking about mathematical proficiency, which kind of started with, awesome stuff in the reading world. We have Scarborough's reading rope, which you and I both really like that model. Like there's so many things, it's intertwined. There's a lot that goes into learning how to read. And we were talking, and this was a while ago about, kind of like reading. Being good at math isn't just like one single skill, but people talk about it like it is, right? And can you imagine if people walked around saying, well, I'm not a reader, or you know what I mean? Like, but I get that comment all the time when I tell people what I do for a living. Oh, I'm not a math person, right? And so it's more about, it's a blend of things where, it's not a static, you have it or you don't. And so we wanted to talk a little bit more about what are those mathematical proficiencies and kind of present to you our idea of what a mathematical proficiency rope would look like. And it's a lot more simplified than you would think, but it is complex, right? When you really break it down. So, Heather, I'm so glad you're joining me for this one. And it's going to be a lot of fun. I've been looking forward to this conversation for a long time.
Yeah, me too, for sure.
So, first off, what are the strands of mathematical proficiency, in your opinion?
Okay, so we kind of broke it down to three strands, semantics, procedural, and verbal. And we'll talk about what each of those means and the
Yeah,
components that go into those.
absolutely. That sounds really good. So, like when we say math semantics, what are we really talking about?
So those are the big conceptual components, the overarching ideas about how numbers work, how the operations work. Many people would call that number sense, right?
Yeah, that makes sense. It's kind of like the magnitude of understanding how the numbers actually work, either how big it is, how small something is.
Right.
Well, what about like the procedural fluency part? That was the other strand that you mentioned.
Yeah, so that strand is more about knowing and efficiently and accurately using things like algorithms and communicating your mathematical ideas. So, not just having that number sense, but how can you write that down and share it with others efficiently?
Yeah. And I think that's something that we see like with a lot of kids who are gifted in mathematics, but they struggle with the communicating that process that was going on in their mind, right? And so that's something that you can work on and target with a student is to help them really get better, more proficient at documenting what they're thinking and showing someone else what they're doing mathematically in their mind. Well, what do we mean when we talk about the verbal area of mathematics?
Okay, so that verbal strand, which honestly is often overlooked. I think sometimes people think of math vocabulary, and that makes sense, but there are really more parts of linguistics that are a part of this. So, math fact recall is something that falls in that verbal area, and people often don't think about that. But in the brain, retrieving those math facts really is a verbal activity. The phonological loop more and more is being implicated with retrieving math facts, and so we're talking about math vocabulary, math fact recall, and even things like morphology of when you're learning the math vocabulary, talking about things like story problems. So that verbal piece is really important and it often gets overlooked.
I totally agree. And I see this play out with my son, who, if we were looking at the strands, his semantics is a really thick piece of this rope. But the procedural and the verbal parts of it are a little bit smaller. And when you look at his testing scores, he does really well when he's doing the computations and he's thinking through things mathematically. As soon as you introduce that linguistics part of it, it becomes a big struggle. And that's where his scores start to dip. But when he was younger, he didn't even get identified as being a gifted thinker in mathematics because that math fact recall was slowing him down like crazy. So once we started working on some of those things more diligently in a better organized way, it got better for him. But the linguistics, vocabulary, word problems are still very much a problem for him.
Yeah, and that I like how you brought that up that a student doesn't necessarily have to be good at math or bad at math. They can have strengths in these different strands and weaknesses in others, and we're working to blend those together so that we have a strong, sturdy math rope.
Yeah, absolutely. Absolutely. So let's dive into a little bit deeper. So we've got the high level, again, it's semantics, procedural, verbal. So let's look at the semantics, the know-how, the knowledge of how numbers work. So what are we more specifically talking about?
Sure. Okay. So we talked about how this is kind of the number sense area. So that could be things like patterns, counting by certain numbers, or noticing patterns that are visual. That can be magnitude of numbers, understanding that three ones is very different than three millions, and understanding that pattern of each period in numbers, your thousands period, your millions period. Sometimes if a student has difficulty in this area, then they're really just struggling with those conceptual components, the big overarching ideas about how numbers work. So they might struggle with estimating or reasoning if their answer is correct. They might struggle with understanding basic operations. Maybe they're not understanding place value and how things are put together, and so then they're not understanding the operations. And you'll often see that these kids can throw out answers and not even register the answers way off and doesn't make any sense.
Hmm. So what types of students are going to be really struggling with some of those things? If we had to put some identifiers, diagnostic criteria around them.
Yeah, so often that can be kind of a red flag for dyscalculia when students really just rounding and estimating some of that basic understanding of math before we even get into the algorithms is just really lacking. But sometimes you also see that students with visual processing difficulties might struggle with this. Maybe they've been using manipulatives or images in class, but it's been kind of cluttered and overwhelming for these students. So it can be really important that we're careful about that because they need that concrete physical experience and the visuals, but we have to present it in a way that's not overwhelming for them.
Yeah, absolutely. I know for me, I relate hugely to that. Like some of the magnitude things that I struggle with is like, I'm totally ousting myself here, but when I'm driving in a car and Google Maps says to me, it's in 500 feet, you're going to turn right. I really struggle with how much is that, and I was thinking about that today with a ruler, and I really don't like rulers because the way they're displayed visually, I start to get overwhelmed. And then I'm trying to remember, okay, it's the longer tick, a half inch measurement, or is it quarters? And so I think I struggle with some of those things too, right? And those things can be beneficial to all learners to have more clutter-free visuals and real world experiences to help
Yeah,
make sense of the magnitude of these numbers, right?
right.
Yeah. So what other things can we do to help students with the semantics part of it, with that knowing how things work?
Yeah, so especially for our students with dyscalculia, we need to be using manipulatives and picture models. We're helping develop that inner number line. Students with dyscalculia often don't have that natural sense of an inner number line of the numbers increasing from left to right. So we're working on those picture models. We also might help with different orientations of a number line, like a vertical orientation, because students sometimes have a better sense of quantity increasing as it goes up rather than left or right, especially if they have directional challenges with mixing
Mm,
up left and right.
hmm.
So we're working on that, making sure that our visuals are clutter free and they support rather than distracting. Don't have a visual just to have a visual. The visual needs to illustrate the math concept. Leave out the other cutesy cartoons and things like that. Those just distract our students.
Yeah.
They should be organized for efficiency. So one of the things we've noticed is if the images are all lined up in one line, the kids have this tendency to count one by one, and then they often tend to count one off, and it really just causes them to be inaccurate. So when
Hmm.
we present our visuals, we're always trying to prevent them from being one off and counting one by one. So we give a subatized visual. So like a dice pattern of 5, for example, a kid could automatically see that that's 5. And that way they can focus on the quantity and move on to the concept. Instead of 5 in a row, they're more likely to just count them one by one. Then they're overloading working memory.
Yeah.
And we also like to use color coding for emphasis, but again, don't overdo it because that can become a distraction. Just make sure that your color coding helps emphasize what you're trying to teach about. Um, the research also supports when you're using manipulatives that they should be generic manipulatives. So when we talk about abstract, sometimes we're thinking of just numbers, but in this case, you could actually have concrete manipulatives. Some are going to be more abstract than others. So things like paper money, kids are more specifically thinking of money, whereas something like a block, they could apply that to other things. And so the research has found that we really need to work with kids with some of those more generic manipulatives.
Mm-hmm.
They can transfer that to other things. If I do all of my math learning at the concrete level with paper money, for example, and then the students need to tell a story about putting together some animals and adding them together, they're going to have a hard time applying that story to the money because money is really specific to purchasing, right?
Yeah,
And
that makes
so,
sense.
so we need to be using those generic manipulatives, like cubes and things like that, that we can assign to many different stories.
Ah,
Um, we also want to be really systematic with the manipulatives. We're not just putting them out there and sort of expecting the kids to discover the information. We really want to explicitly tell them what to do with the manipulatives, ask very direct questions about them. We're not trying to just discover things. We're being explicit. The research supports that, especially for our students with learning differences.
right.
One of the things we call that, so sometimes we hear this concept of CRA, concrete representational abstract. We've talked about that on the podcast before. And sometimes you'll hear the concept of CRAI, and they've added that I to show, okay, we're integrating those experiences. So not only are we using the manipulatives, but we're using that side by side with the numbers because we're helping students map that concrete area. If we're talking about students with dyscalculia who were weak in that area, we need them to map that area of weakness to their other area, the abstract area, right? And map those two together so that the abstract has a meaning. So we always are making sure with our manipulatives and our visuals, we're doing that side by side with the numbers.
Yeah, I think those are great ideas. The CRAI is a game changer. I really appreciate the efforts that goes into making sure we're mapping things kind of like a grapheme and the sound, right? It's the same idea.
Right.
So let's move from semantics and we're going to hop to procedural. So what might it look like? Actually, let me back up. What's all involved with procedure? And then what does it look like if a kid's struggling?
Okay. So the procedural fluency involves the abstract written numerals and the symbols. It's about knowing and efficiently and accurately using those algorithms and communicating mathematical ideas. This could be counting, ordering, sequencing numbers. And if a student has difficulty with this area, you might see that they're struggling with planning, sequencing the steps in order. Sometimes it could be students with processing speed difficulties. It could be students who struggle with working memory, and
Mhm.
that can cause this area to be really difficult for them. They might struggle with remembering the algorithms or getting the steps from the algorithm in the right order. And you often see in the classroom, it might look like those students who you're getting those comments from teachers like, oh, they're always making careless mistakes.
Yeah.
Because somewhere along the line, their working memory is getting overloaded or they're struggling. And so you just start seeing that they're making these mistakes. It also sometimes look like students who sit there and don't get started. And it
Mm-hmm.
might look like they're being lazy, but actually it's because they remember the steps, but not really the order. And so getting started is overwhelming.
Yeah, that makes a lot of sense. So, what other kinds of students would we see? Like, give me, I guess, a few more examples. Like, that kind of feels like executive function world, but I know it's more than that.
Yeah, definitely. This can also be students who struggle with directionality or who have dysgraphia.
Mm,
You think about the multiplication algorithm, for example, you're going all different directions, right? The ones times the tens times the ones. So that directionality issue can really mix them up. Um, and also place value. You got to think about going down your columns for each place value. So if you're struggling with directionality, you might add across the rows instead of down the columns.
yeah.
You might correctly regroup, but you're getting the wrong number because you've gone across instead of down.
Yeah. And I think some of that too can just the kids get confused, like what instructional approach they were taught, right? I think about sometimes I see teachers doing partial products out to the side, to the right side of not an equation, but a problem that's stacked. And the kiddos, right, again, directionality are kind of confused about what they're doing. And so it's easy for them to get, yeah, lost in that. I
Yeah.
think the other thing we mentioned procedural fluency. That is a trigger word for a lot of people right now because it's gotten a bad rap. So, what do we really mean when we say procedural fluency?
Yeah. So we're talking about efficient and accurate calculations that are not taxing working memory. So let's do some examples of what is not procedural fluency. So that's not things like invented algorithms. Sometimes this can be trendy. Let's have kids invent algorithms. But the problem is those algorithms at the lower level show up in higher level complicated math. And so if kids have kind of invented their own algorithms, often, for one thing, it's not really efficient for them to come to these algorithms. These were developed over hundreds of years as people found what was more efficient and what supported higher level math. Um, but also, they might come up with something that works for now and then it hurts them in the future because it's no longer
Yeah.
accurate later. So, we're not talking about invented algorithms. You need to know, for example, subtraction with regrouping to do the long division algorithm. And then you need to know the long division algorithm to do long division with polynomials. So all of these things are important. They are done the way they are for a reason. And so
Mhm.
it's important that we support students in that. Um, Another thing that is not procedural fluency is just teaching students a lot of strategies and kind of expecting them to use those to come up with an answer. Um, a lot of times, for example, math facts, just knowing the math fact is going to be faster than trying to reason through. And so you might be talking about strategies like doubles or doubles plus one as you're building your numeracy, right? In those younger years and thinking about math. That's part of numeracy. But when you need to know 6 plus 7, you just need to know it. You don't want
Mhm.
students to be still trying to derive it because then when they're trying to do multi-digit arithmetic, suddenly they're going to overload working memory because they're using this strategy to try to remember the doubles and then add one and then, oh, where was I at in the problem? That doesn't work for students. So it's really important that they're learning those algorithms, they're getting them all the way fluent, they're learning their math facts, which we know for some of our students that can be a challenge. But we have also seen with our students, I don't think we've ever had a student who can't learn and make progress with math facts. It is sometimes slow, and for some kids, it maybe even is painfully slow. But the research really supports that most kids, even kids with learning differences, can learn their math facts. So that is something that we work on. That's probably a whole other podcast in and of itself of how to learn your math. But
Can we give people like an example when we say slow? Because I think everyone's definition of what slow is would be different. But when we say slow, what do you mean?
oh, sure. I mean, it does depend on the kid, but for some of our kids with learning differences who struggle, especially, dyslexia, you can struggle with word retrieval, and that is what you're doing when you're retrieving your math facts. So for these kids who are expected to learn all their multiplication facts in 1 year, even with a really solid program that's taught really well, you'll find some of those kids may not have mastered the facts in a year. And so that's something we want to continue working on. It doesn't mean that we're going to give up and give them a calculator in third grade.
Yeah.
Right? Like we're going to keep working on that, but also they're going to need some supports in between until they can get those math facts learned.
Yeah. I think that's a really good thing to point out. Um, so as far as I'm just curious, like what kinds of students are we seeing that have struggles with procedural fluency in general?
Yeah, so this can definitely be kids who struggle with executive functioning, like we talked about, sequencing
Mhm.
and planning, processing speed, working memory. That's going to affect being able to use those algorithms efficiently without the right supports, right? So we need
Right, right.
support in that area. Um, a lot of times for us, that means we might have some little visual symbols that help them get those problem steps in order. Sometimes in upper grades, it looks like having some worked examples that show you how to break down the problem step by step. Um, Sometimes, you could have things like with division, we have some like karate moves. So you're gonna divide, multiply, subtract, check, bring down to help students
Right.
remember those steps, get them in order. Sometimes doing those gross motor actions can help with retrieval. Sometimes you'll see that there could be an acronym that's used, like Romans is one that we use for story problems when we have that attack
Mhm.
strategy. And each
Yeah.
letter in the word Romans stands for part of what you're supposed to do when you're breaking down story problems and figuring out the schemas.
That stuff can be really powerful. I got a really sweet email from a student way back in the day, and he just wanted to reach out to me and tell me that he was doing well in math in college,
Aw.
and that every time he works with X and Y axis, he thinks of me because the Y axis was, it's straight up, man. And he would do his arm straight up. It's straight up, man.
I love that.
It's cute. You just never know what will stick for that kiddo, but those kinds of things can really, really be helpful. So I
Yeah.
love the ideas that you shared about having like a graphic organizer. And we've also talked briefly, like we hinted at it, about worked examples and possibly buttons. Can you explain a little bit more about like what a button would be?
Sure, yeah. So we call it a button because it's a little visual, it has a symbol of what to do. Um, but ideally, the student would have that by their left hand. If they're right-handed, they're writing with their right hand, and then their left hand is touching the step that they're on to help them keep track and sequence them in order. So that's why we call them buttons because you're touching each button. And so for division, which we mentioned earlier, which starts with divide and then multiply, you might have a little picture of a division symbol and then a picture of the multiplication symbol. The bring down might be an arrow that's going down. So having those little visuals is helpful. Worked examples can be good too, but even, that takes a lot to
Mhm.
walk through and look at each step. So having just that little picture reminder is good. And students can be provided those visuals at first, but also we know on tests they can't take those types of things in. But if students have been working with those visuals enough, you can help students transfer eventually to practice. Just draw out your little steps if you need to. Sometimes, after working with it long enough, they have that mental picture. But if they don't, sometimes they can practice drawing it out at the beginning of the test so they have their near point reference and then they can use it on the test.
Mhm. I think that's really, really powerful.
Another part of procedural fluency, too, is just practice. And it might seem silly that I'm mentioning that, but sometimes we teach kids a concept and we think, okay, they understand it now, and we just move on. And we don't understand that we have this piece where kids need to practice it enough that they really own it. It's automatic. It can be then applied to higher level math. Otherwise, they're kind of just stuck in that acquisition phase and they don't get that procedural fluency.
Mhm. Yeah, that makes tons of sense. Yeah. Yeah, making sure we're giving them plenty of practice.
Yeah, our lesson
Um,
plan has a part for that actually at the
yeah.
end, an independent work piece, because sometimes we don't realize as teachers that students understand it, but only with the cues that we're giving.
Hmm.
So if we really want students to be able to do this independently, we need to give them a chance to do that and work independently, but then also get some quick feedback after that if there are any corrections that need to be made, things like that, so that they're developing that fluency.
Yeah, absolutely. Well, I think there's so much more we could talk about around the procedural part, but let's move on to the verbal proficiency strand. I'm curious more about that. So let's dive a little deeper about how linguistics and math facts play a role in that verbal piece.
Awesome. So yeah, within linguistics, we've got those vocabulary words. But we can break that down even more than just teaching the words. We can teach the morphology, teach the root words, and you'll find that a lot of times teaching that in one word will unlock something else. So if we've taught the word equal, for example, well, later we have words like inequality. And if we know equal and we know in means not, then we can say,
Mhm.
okay, an inequality is a statement that is not a statement of equality. It's the opposite, a statement of two things that are not equal.
Mhm. Yeah, I think that's really helpful. And I think the other thing too is teaching more directly words like is and of have different meanings in a math sense than they do when you're just reading a book. And I know a lot of students with dyslexia, without necessarily realizing it, are skipping over those words when they're reading because it doesn't have a whole lot of meaning for them. But then they get thrown into this mathematics world and now it has meaning. And they're confused, right, about interpreting that into some sort of symbolic number format or an equation. And they really struggle. So they have to be taught those kinds of
Right.
things. Yeah.
Right. And we're helping kids to build some of those schemas. So not just taking a word only and teaching the meaning and saying, oh, anytime you see and it means plus, because that's not always
It's
the
not
case.
true. Yeah.
So helping students learn the meaning of those words, but also apply them to schemas. We've talked about this a little bit more on some other episodes, but
Mhm.
understanding those story problem schemas, the types of things you're typically going to see in your story problems, and being able to pair the words with also what's happening, the actual schema underlying that problem. So there's really a lot going on with language and vocabulary. And then we talked about this earlier, but math facts, you'll find a lot of the kids who struggle with that rapid letter naming and rapid number naming. They often struggle with retrieving those math facts. It's kind of like for any of us when you can think of a word and you can picture it, but you can't seem to say it.
Mhm. Yeah.
Right? So that can happen with our students too. So often students with dyslexia, sometimes students with auditory processing difficulties can struggle in this language area, this verbal area, or students with slow processing speed can struggle, not because they can't understand the language, but because you're going too fast for them. And so they need you to really slow down your rate of speech and add those processing pauses in between
Hmm.
because they're really struggling to hold on to what you're saying and they're thinking at the same time.
Absolutely. So what can we do to support students that are showing that they're struggling with this verbal part?
Yeah, so obviously we talked earlier about practicing the math facts. And so for some of our students, the ones where the progress is painfully slow, one of the things that we might do is chunk those math facts into smaller groups. So sometimes maybe you're only learning one or two math facts. So maybe you're working on 3 times 4 and 3 times 5, and we're just chunking it into a smaller amount. But for some kids, because of that phenomenon where you can picture it and you can't seem to come up with the word, pairing that with a visual can make it easier to retrieve. So picturing, if you're doing, let's say, 3 times 5, picturing a die with five, picturing three of those, that's an easy visual to picture. Okay, I can see my three groups of five. and I can see that two of them make the 10, and then we have five left over. So I can see that my answer needs to be 15. So that can help students for sure. You can also add rhythm. So I know for one kid who was really struggling with 7 times 8, we would chant 7 times 8 is 56. And it wasn't a whole song of every multiplication fact they had to go through to get to that one. It was just our little chant, almost like a jingle for
Hmm.
McDonald's or something, right?
Yeah.
um, just for that specific fact. That can help. Um, we also find that it really helps students to do related facts. So if we're working on 3 times 5, if we also work on 5 times 3 and 15 divided by 3 and 15 divided by 5, relating all of those together can help, especially for impulsive students who maybe know, okay, we're working on 5, so whenever I say 3, or whenever I see a 3, the answer is 15. Well, then when you move on, you're not on fives anymore, you're on sixes. They're used to just saying, oh, whenever I see 3, the answer is 15, right? And so those related facts can help students really pay attention to each piece of the fact,
Hmm.
just sort of skip over it. Um, but obviously, I mean, those are extra strategies for kids who really struggle, but all of your basic strategies as far as, interleaving and retrieval practice, it's great. I love having a deck of cards by me with students. So I'll pull out my deck of cards, whichever facts we're working on, we pull out those cards so that we can kind of flip through them. And with students, if I see that they've missed one, they'll set it aside so we can come back to it. And sometimes we'll try to do every other, like do the fact that's known and then go back to the one they missed, and then, go back to a known fact, go back to the one they missed. And if they're getting it, start spacing that a little further and further apart. Um, but even just doing a couple minutes each day of that quick retrieval, it doesn't have to be in a worksheet if students are really stressed about that. For a lot of students, that actually does work really well. Sometimes worksheets get a bad rap, but that timed practice really does have a lot of research backing that it will help most students. But for those outlier students, we got to think about how we can support them if they're stuck and you're right. If they're doing a mad minute and they're not making practice on it, something has to change.
Yeah. Yeah.
We need to restrict the facts more or figure out what is it that's making the student not progress. Because for some of our students who are just being given these mad minutes and they're not progressing, instead of teaching them math facts, we're teaching them that they can't learn math facts, which is
Yeah.
not true and it's not fair. That's just poor teaching practice.
Absolutely. So what about like the language part, the vocab? What could we do
Yeah,
there?
Yeah, so we talked a little bit about teaching the morphology there. A lot of it too is just making sure that you actually use those words regularly. Sometimes teachers come up with other words they think are more student friendly, but actually you're doing a disservice to students because they're going to go on to other higher levels of math and they need to know those words. Math is a language, so we need to know those words and be using them. If kids can learn to say things like skibbity fortnight, then they can definitely learn to say this math vocabulary like equals, right? So
Yeah. Hmm.
they can learn all the names of the Pokemon. They can definitely learn these math words. So making sure that we're practicing those, we're teaching root words and morphology, we're using gestures, which we have our own vocabulary words and we've come up with gestures that go with each one so that we can practice with that gross motor. Um, just like when kids are doing schemas, for example, and they learn the actions for each schema. Sarah Powell said that when you say, okay, tell me what schema do you think this is? A lot of times kids will do the gesture instead of saying the word because
Oh,
that
that's
motor
interesting.
really
Yeah.
sticks with them.
Hmm.
So
Hmm.
that's something that we do. We're also helping students to develop that inner monologue of what they're saying to themselves. So they're not just relying on our cues. Short and snappy phrases that are easy to retrieve. I love Marilyn Zecker's language of how many groups of blank can I make out of blank when we're doing
Yes.
division. And you can use that all the way up into higher levels. I just did that with a student with integers, and it was really helpful for them. Um, but I also often, when I'm transferring that language, if I'm used to saying that, I want the student to own that language. So I might say to them, what do you say to yourself when you divide? So I'm kind of prompting them to retrieve that language, but I'm not actually saying to them what to say to themselves. That's part of helping them develop that automaticity with that language.
I love that.
You can also definitely apply any of those science of reading tips to your math classroom. If you're reading story problems, stop at a period and reflect about what's happening in that sentence. Um, Teachers can provide story problems with easy to read names to support some of our students with dyslexia who are trying to read these problems and maybe aren't totally proficient readers yet. And teach students to answer their story problems in complete sentences. And what that means that each sentence has a who or a what and a what's happening, and that you can go back to the question and look in the question who or what is the question asking you about, and then the what's happening part, and tie that to your number answer. That will help students check their work too if they have an answer and then they realize, oh, wait a minute. I said that the answer was 8 eggs, but the question wasn't about the eggs. The question was about the cartons.
Mm-hmm,
Answering
mm-hmm.
the sentence can help them check that.
Yeah, I think that's really key, and it helps them in the long term, right? Being
Yeah.
able to communicate a complex idea to somebody else. And that's another thing that I love Marilyn teaches us is to coach kids to be a word thief. Go steal some words from that word problem and put it in your sentence, right? I think those are really helpful things. So those are the three strands. We've shared a lot of things kind of high level, and you're probably wondering, like, oh gosh, how do we learn all of these things? And really, I know what I think about this, but I wanted to ask you, do you feel like teacher education programs are teaching how to support students to have mathematical proficiency?
Oh, that's a good question. And what I find is there tends to be kind of this math war. And so you've got one side where people are really focused on the concrete and visual piece, and they'll kind of pit that against the procedural fluency piece. And I don't know why, but we've turned it into this binary fight instead of realizing that they are both strands that need to be woven together in our rope. And that verbal strand often kind of gets ignored altogether. Like people think
Mm-hmm.
of it as language arts or something. They're not really seeing how important that strand is. Maybe they teach vocabulary, but usually don't use it enough. They usually don't talk about morphology. They're not talking about, that easily retrievable language for students and developing that inner monologue. So we really need to have all of those pieces together. And teacher prep programs or curriculums seem to usually just focus on, one of those two binary fights. They'll be really great with using lots of manipulatives, but maybe not very good about doing so explicitly, not really teaching algorithms and mapping the two together. Or they'll be really great about procedural fluency in practice and breaking things down step by step, but they'll just totally leave out the manipulatives and visuals. And so it can be hard to find something that helps you marry all three of those strands together.
Yeah, absolutely. So what can we do? Like, how can people get more information about how to interweave these things?
Yeah, well, one of my answers would be that we've tried to take that and teach it to our own team. And as we've built resources for that, we've put it together into one portal. So it's now something that's available to the outside public to actually watch our training videos, things like how learning differences affect math and how to teach each content area, how to teach the hands-on and representational, how to map that together with the abstract, how to add the language piece in there and really have that full math rope. Because what happens is just like in reading, where we have kids who maybe have dyslexia and they're getting behind in reading, and we have what they call the Matthew effect, where because they're behind, they get more and more behind because they can't access the new content, right? So we see that in math too, that if you're missing one of those strands, then you start to have trouble accessing the other strands and you can just get weak across the board. So we've tried to put together all these resources so that families or teachers at school, other tutoring centers can take the curriculum that they have and the good pieces that it has and then know how to supplement for our students who need more individualization. And even just the piece for all students, those pieces of the math rope that are missing in your curriculum, we've taught how to add those pieces in.
Yeah, I think that's a really great solution because there is training available and we've taken a lot of that training. But then there's also missing pieces even within that where, research that maybe wasn't considered when they put it together. And so we've tried to be really in depth in what we put together, but in a user friendly way, right? We've read, I mean, you see my library behind me. We've read a lot of math books. We've learned how to implement these things. But I know that often when I finish reading a book or taking a training, I have this sense of, well, now what, right? I know this is what I'm supposed to do, but now what? And really, the CRA club is the work that we've put into figuring out the now what part. And here's how you implement it with kiddos. So if you're looking for a solution, yeah, I think that would be a great one to figure out.
Yeah, yeah, definitely. Because this is what we put together when we finish some of these, like a 1 week intensive training or things like that. And then you go to do it with students, overwhelmed, right? Like our working memory, right? It's not
Yeah,
the for
yeah,
student. So we've tried to put this together in such a way that you can go back and review, okay, here's a quick visual of exactly what I watched and what I need to sit down and do with students, a reminder of the wording that you need to use, the vocabulary cards are already ready. So we just making it so you could put more of your time and focus into the actual teaching and less into the overwhelm of trying to
yeah,
figure out what to do.
yeah, absolutely. Well, Heather, I really enjoyed our conversation. I think we could keep going deeper and deeper into these. It's a complex idea. But I like the rope that we've developed here with those three strands. They make a lot of sense. And when they are supported appropriately, we've got a really great mathematical thinker on our hands. And I love that we both know that that's possible for students that maybe didn't feel that way before. But as they work in an environment that's tailored for them, they start to see that they can do it. So anyways, for those of you listening, come over to madeformath.com/CRA club to check it out if you're curious about that. But we have mountains of resources that you can further your own education, either here on the podcast or on our blog posts. There's lots of directions that you can go as you explore and learn more about each of these strands. So to wrap it up, I know we like to get a joke going. You had a really great one the other day at the CRA club, so I thought I'd have you share it.
Sure. Okay, yeah. So this is a visual one, so I'll describe it for anybody who might be listening. So it was a graph and it was titled What Gives People Feelings of Happiness? And it had 3 bars on this graph. So there was money and there was status. And then the last bar, which was the longest bar, was the childlike excitement you get when you ramble about a topic you're interested in to another person who is willing to listen. That's
I love
really
it.
what we just did right
That's
now.
exactly what we just did. I really enjoyed it, and I hope others did too. So, thank you for joining us, and we hope to have you inside of the club.